Hello, everyone. My name is Priya. Nice to meet you all. I am a director of engineering at Chainguard. I have worked there for the past 4.5 years. I was actually one of the first engineers to join the company, and it's been a really crazy ride going from a small team of 15 people to almost 600 now. In that time, I've seen our team evolve, our product evolve, and today, we're going to be talking about a lot of our infrastructure evolving over the past few years, especially in the past year as we've introduced AI agents into our workflow. So, for those of you who may not have heard of Chainguard before, we're a company whose mission is to secure open source software. So, I think probably everyone here who's ever written code has used open source software, whether you're pulling dependencies from PyPI or maybe using a public container image from like a Docker registry. So, everyone here has used open source. Probably you didn't really think too much about where that code was coming from, who had written it, or how it was built. And that can introduce a lot of security risks into your software supply chain. So, the goal of the company is really to secure open source software so that you can continue to use it, get all the benefits of open source without the risk profile. So, today's landscape, whether you really think about it or not, when you're using open source software, you're basically trusting a bunch of other people and their build environments with very little insight into what's actually happening and how that software is being built. And it was always kind of scary, but you could kind of, just not think about it too much. It's even scarier now that we have AI. So we're probably all writing way more code than we were before. It's easier than ever to open source something. You might not even be looking at the code that you're writing half the time, and then other people could go in and use it. And at the same time, we have these new models like Fable and Mythos, which are amazing at finding vulnerabilities in software that we ourselves haven't even discovered yet. So at the same time that we have way more open source out there, we also have these tools that attackers can use to pin together vulnerabilities in new ways and create really bad security risks for all of us. So that's kind of the challenge that the company is trying to solve. And I'm going to talk a little bit about the factory that we've built today to keep open source secure so that end users can just continue to use it and they don't really have to worry about the risks as much. So, yeah, another slide kind of just making the same point. I'm going to skip this one. Cool. So the chain guard factory. So this is the factory that we've built that we rely on to basically keep our software secure. How we measure security is we scan for vulnerabilities in that open source software. So if you've ever used like one of those open source scanners like Gripe or Sneak to look for vulnerabilities in your code, those are the exact vulnerabilities that we are trying to remediate. And that's what the factory is for. So the SLA that we have, the SLA that we have was actually inspired by FedRAMP. So if any of you have ever had to be like beholden to FedRAMP requirements, I think it's like 90 days for critical and high CVE remediation time and 180 for medium and low. I might have that a bit wrong, but it's something like that. Um, our SLA is a lot more strict. So as soon as a critical CVE is discovered in any of the open source software we track, we want to patch it within 7 days, and it's 14 days for high, medium, and low CVEs. So these are kind of the restrictions that our infrastructure needs to be able to ensure. So I know when you like give a talk, you're not supposed to put a ton of text on the slide, so sorry about this. I'm not going to go into all of this, don't worry about that. But just at a super high level, this is kind of how our factory works. So on the left side, we're bringing in open source software. We track a bunch of different things like new releases on GitHub, new CVEs being discovered, software going end of life. And we want to track all of these things to make sure that our Linux distro, which I'll get into, is as up to date as possible. The reconciler loop in the middle, that's our factory. It's a combination of bots, agents, and occasionally engineers who basically keep the software secure and keep the factory running. And then at the end, once the factory has successfully secured the open source software, we output it as an artifact for your consumption. So that artifact could be a secure base image that then you build your application on top of and deploy to the cloud. It could be Python, Node, or JavaScript dependencies, which you then pull from us instead of something like PyPI. And all of our software comes with security metadata. So that's what really also sets it apart from just pulling directly from open source. It comes with an SBOM, so you can see exactly what dependencies went into that piece of software, and it comes with software signatures so that you can validate that the piece of software was actually built in the Chainguard factory and not just on some developer's machine. So I'll start with Chainguard OS, and today I'm really going to talk about our secure container images product. It's mostly because it's our biggest one and usually the most interesting for people, but the philosophy that we've kind of put on our images product really extends to all of our other products as well. So when we started building out our own Linux distro, we did it because we thought it would be easy, and it wasn't. But I think it was a really good thing that we did it because it really underpins our container images and allows us to keep them CVE free. So our Linux distro is an offshoot of Alpine based on glibc, and every single package is built from source. And the thing that sets us apart is that our OS is really designed for continuous nano updates. So as soon as like a new version of curl comes out, we should have that latest version in our distro like within a day or two, versus if you're maybe using a more popular Linux distro, you might only get the releases every few months. So if you've ever been an open source maintainer, I've maintained a few open source projects. Whenever a CVE is discovered, what we typically do is we try our best to patch it and we just release a new version. So if you want that software without the vulnerability, you have to upgrade. And knowing that that's just sort of how open source works, that's why we knew we wanted an OS that could withstand these continuous updates so we could always be at the latest version of software so we can minimize the vulnerabilities in that software. So a little quick dive into how these packages are actually configured. So I think built from source, if that's like the one thing you remember, that's kind of our philosophy in general. So we build everything from source, which eliminates like a large class of supply chain risks because we have our own build system and we're not relying on anybody else's. So in this case, we're building from a particular Git repo, particular tag, and we specify what commit that package should be built at. Building it with Go, we run some tests to make sure that it actually works. And then we have bots which keep that package up to date. So bots constantly watching open source, waiting for new versions to come out, and then going through and updating these packages. So here's like an example of our automation at work. We had an update to a contour package came out. So you can see a bot opened up a PR. We bumped up the version, bumped up the expected commit. We ran like 20 checks on it. I think today it's more like 30 or 40, but we run tests on them. We run CVE scanners to make sure we haven't introduced new vulnerabilities with the new open source code being brought in. And we run malware scanners as well to make sure we're not pulling anything, suspicious. And if all those checks are green, then we automatically merge the PR. That package gets built and added into our distro. So then on top of the distro is how we build our Chainguard images. So every single image is basically a compilation of some subset of packages. And these are also built and tested every single day. So since we build our images every day, they're always going to be built on top of the latest version of packages. And so that's how we keep them CVE free or low CVE. These images also get signed, so you can actually go and like verify the signature on the image and make sure it was built in our particular build system. Every image also comes with security metadata. So SBOMs, I think, are a pretty common piece of security metadata at this point. So you can see in this one for our Python image, we have all these different packages at a particular version that have been built. And if you wanted to, you could trace back to the source code exactly how each of these packages was built by going back, checking on the package config that I had showed earlier, seeing exactly what commit that thing had run at, and exactly what commands were run to build it. So you get this like very easy to follow audit trail of exactly what you're running in your environment, which you don't really get when you're just pulling something from open source. So how do we address CVEs? Because that is kind of the crux of the business, right? That is the SLA that we're trying to uphold. So we continuously scan our images. Images are scanned every day. As soon as a CVE is discovered, we jump into action. Well, the bots jump into action at first, and then if humans need to, they will. So a lot of CVEs can actually be automatically remediated just by bumping dependencies. A lot of the time, if you have a CVE in your code, it's because a dependency that you depend on actually has that CVE, and you can just bump up the dependencies automatically, rebuild the piece of software, retest it, and if everything works, then you've successfully remediated that CVE. So we have a lot of automation that takes care of that for us. And in the case when automation can't handle it, we fall back on agents to try to fix it. For every CVE that comes up, we file an advisory. So you as a user can actually see exactly what we did with every single CVE that was discovered in our software. And the cool thing about this is that, say a CVE is a false positive, a lot of times scanners will find things that aren't real problems, right? We have automation and we have humans who will go in and mark that CVE as a false positive. We publish all of our advisories, and that advisory feed is something all the popular scanners depend on. So if you're using like a Sneak or a Gripe, they actually know how to read our advisory feed. They'll see that Chainguard said, hey, like this CVE was a false positive, no need to worry about it. And the next time you scan your software, it actually won't flag that CVE as a risk. So it's pretty cool. And yeah, just another visual of a timeline of how we address our CVEs. So coming back to the bigger diagram, we ingest open source on the left-hand side. New GitHub releases, public registry feeds, new CVEs, these are all inputs to the factory. Once we're in the factory, we basically have a reconciler framework where we have our current state and our desired state. And we will fire either bots or agents to get from our current state to our desired state. It's kind of similar to like Kubernetes architecture, if anyone's familiar with that, kind of on purpose, I think heavily inspired by how it works. But we start with just static bots, keep costs down, and a lot of times they work pretty effectively. So we have bots to update our package versions. We have bots to fix tests. We have bots to remediate CVEs. And a lot of times they do really well with the simple tasks. Say the bots, face more complex tasks that they can't handle, then we fall back to our agents, which can reason about more complex failures and have a little bit more power to try to fix things. So we'll fall back on our agents, which can analyze our failing test logs, or agents which can try to actually write real patches for CVEs versus just trying to bump dependencies. And so this kind of combination of bots and agents allows the factory to run really smoothly. And it's a lot of work when you think about it, like maintaining an entire Linux distribution and trying to remediate critical CVEs within just a couple of days. Like it's constantly churning, constantly rebuilding. If we find a CVE in a small package only a few people are using, it's not a really big deal. But if we find a CVE in Go, not only do we have to rebuild the Go package, but then we have to rebuild every Go application that was compiled with that Go package. So we can end up in these situations where we have to do full world builds of our distro and then full builds of our entire catalog as well. So we have to have a very strong factory that can withstand that kind of load. And then, what comes out is a variety of hardened open source software in different formats. So secure images, secure libraries, JavaScript, Node, and Python. We recently started working on securing skills, hardening GitHub Actions. There's been a lot of supply chain attacks recently in the GitHub space. So that's kind of what inspired that product. And yeah, a lot of security metadata that comes alongside everything, SBOM signatures, and really quick patches. So value for our customers, 90% typical CVE reduction in images, and we're able to patch things in hours, whereas if you're depending on like one of the bigger, more popular Linux distros, it might take months for the fix to even get released, and then more months for you to upgrade to the next version of that distro, right? We have a really big catalog, 2,400 plus images, and if you're just a developer and you don't want to pay for all this stuff, we have a bunch of free images as well. So you can go and you can take a look at our free images, try them out. Honestly, I think they're probably, if you're going to use a free container image from the internet, just use ours. There's way less vulnerabilities in them. Cool. And that's all I had. Thank you so much. If anyone has any questions or want to talk about anything, I'll be around.
Thank you.
Thanks for listening.